Another way we can solve our quadratic equations is by using the quadratic formula. So here's our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You can remember it by putting it to a song. So when I first learned it, my teacher used to sing this song and write and dance every time she wrote it on the board. Since then, people have become a little fancier, and you can go to YouTube and you can Google, and they have it put to Adele. So if you put in quadratic formula Adele, and you'll hear people singing it to Adele. So you can do that if you like. Make up your own song if you like. But you're going to use this quadratic formula so much in the rest of your math classes, as long as it's an algebra-based math class, which means all the stuff that we've been learning you need for the next class. If it's a class like that where you need the stuff that we've been learning, you're going to have to remember how to factor. You're going to have to know how to use that quadratic formula. And so again, it's just used to solve our quadratic equations. Here I'm reminded about that plus or minus notation that we saw with the square root property. Means we have both the plus and the minus. So plus or minus 4 means you have a positive 4 and you have a negative 4. So to solve these quadratic equations using the quadratic formula, we want to make certain our equation is in that ax squared plus bx plus c format equals 0 format. So everything's on one side, 0 is on the other, and on that side where everything is together, everything is going down with our descending order. And all we're doing is we're plucking off the coefficients. So the coefficient of x squared is our a. The coefficient of x is our b. And that constant, which is the number by itself, is our c. We're going to pluck those off so that we can plug them into the formula. From there, we're going to simplify. We will have to separate it to two numbers, one with a plus, one with a minus if necessary. And I talked about that a little bit in the square root property video. And we may actually have to factor to cancel. So we'll look at 3 examples. The directions are going to say solve. We've seen this 2x squared minus 8 equals 0 equation before. We saw it with the square root property. And I even mentioned there how we would have been able to factor to solve that one as well. And so now we're going to look at that exact same problem using the quadratic formula. Now what should happen is what happened before, where both answers match. So now we should have a third method and still get the same answers. So I have everything on one side, 0 on the other. But I'm missing the piece with the x. And so that my eyes are not tricked, I'm going to plug that piece in with a 0x. So 2x squared plus 0x minus 8 equals 0. So the coefficient of the x squared is 2. The coefficient of the x, which is our b, is 0. And the constant is negative 8. A is for x squared, b is for x, and c is for our constant. So our a was 2. We didn't have the x part, so our b was 0. If you don't have that part, then add 0. And then the constant was negative 8. So we're going to take that into our formula. Another way to memorize the formula is to keep writing it over and over and over again on your paper every time you work the problem. So our x is negative b. Remember, I like to put my stuff in parentheses when I'm plugging it in, and then I decide whether or not I need it later. So I have negative parentheses 0 plus or minus the square root of the b, which is 0 squared, minus 4. A was 2, c was negative 8. All of that over 2, and the a is 2. So we have negative 0 plus or minus 0 squared minus 4 times 2 times negative 8, all over 2 times 2. So now I start cleaning up. Negative 0, I don't need that. That's just 0. So I have plus or minus. 0 squared is 0. Then I have negative 4 times 2 times negative 8. Negative 4 times 2 times negative 8 gives me a 64. So I have plus or minus the square root of 64 over 2 times 2, and 2 times 2 is 4. Now that square root of 64, if I was paying attention earlier, I would have already started getting it ready for my sets, because my 64 is 8 times 8. Another way to look at it, it's like that. You have 6 2s. So you'll be able to use, you have 3 sets of 2. So 2 times 2 times 2, which is going to be an 8. So if I want to get comfortable with this plus or minus notation, I leave that there. Square root of 4 is 8. So I put the 8 behind the plus or minus over 4. And 8 divided by 4, if I ignore that plus or minus, 8 divided by 4 is a 2. So x is equal to plus or minus 2. And I can write it this way, or I can write 2 comma negative 2. Again, pay attention to the directions on online homework systems. And so yet again, we got the same set of answers. Let's look at number 2. Number 2 said y squared plus 10y minus 26 equals 0. This one is here so that we can point out that we would not have been able to factor that. There's a 1 in front of the y squared, so I would focus on the 26. I would need factors of 26 to subtract to give me 10. Factors of 26 are 2 and 13. That's it. Just 2 and 13, other than 1 and 26. 1 and 26 and 2, 13, neither one of those will subtract to give me a 10. So we would have written prime if we were just factoring this. Now we're solving it, so we wouldn't have been able to factor to solve. That's where that quadratic formula comes in. It comes in when you can't factor those quadratic equations, or when it's taking you too long to factor the quadratic equations. So I need to pluck my ABC. In front of the y squared is a 1. That coefficient is 1. So our A is 1. In front of y is 10. So our B is 10. And our constant by itself is a negative 26. So our C is negative 26. Whatever sign it has, that's what I take. So I have to use my formula, that negative b plus or minus the square root of b squared minus 4ac all over 2a. So I end up with negative 10 plus or minus the square root of 10 squared minus 4 times 1 times negative 26 all over 2 times 1. So I'll have negative 10 plus or minus something big and nasty to clean up, especially if you don't have your calculator like me. So I have to do 10 squared times minus 4 times 1 times a negative 26, all in my calculator, because that's the part that's underneath the square root. So I want to take care of that together. So 4 times the 26 is giving me 104. So I'm have 100 plus 104 to give me a 204. So I have negative 10 plus or minus the square root of 204 over 2. Oh, man. 204. What can I do with that? Well, 4 will work. That's 4 times 51. And the 4 will give me a 2 times the 2. The 51 I can clean up to 3 times 17, but it's not going to help me any. But that 2 times 2, yeah, I'm going to need that. So I have negative 10 plus or minus 2 roots of 51. How did I write the 2? How did I get that 2 roots of 51? The 2 2's made a set from the 4, because we said 204 is 4 times 51. So this 4 gave me the 2 that's here. And the 51, which is the 3 times 17, we had to leave back underneath the radical. I cannot combine a 10 with the square root. So the most I can do is factor to finish this off. And I'm running out of room. Negative 10 plus 2 square roots of 51. Over 2. That's what we had, right? Negative 10 plus or minus 2 square roots of 51 over 2. So I can't combine it. Remember I said sometimes we have to factor. I will have to factor. There's a 2 that I can factor out the 10, a 2 I can factor out the 2 roots of 51. So I factor out my 2. I'm not going to worry about factoring out a negative. I know we said that if there's a negative up front, we factor it out, but I'm not going to bother with it. Come on. This 2 I can cancel with that 2. And it leaves me with negative 5 plus or minus the square root of 51. We have one more example, a third example, and we'll talk about some other stuff, but this is the last complete example. X squared minus 4 equals 3x. And as you've seen the warning, my battery is low, so got to make it quick. On this one, we don't have everything on one side, 0 on the other side. So I do have to take this x squared minus 4 equals 3x. I do have to take that 3x and move it to the other side. It's a plus 3x, so I make it minus 3x. And I'm going to write it right after that x squared so that it's in my descending order. Now I need to obtain my coefficients, my ABCs. My A is 1, that's the coefficient of the x squared. My B is negative 3, that's the coefficient of the x. And my C is my constant of negative 4. Now I plug that into my formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So we will have negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 4 all over 2 times 1. That's plugging in my ABCs. That will give me negative negative 3 is 3, plus or minus the square root. That'll be the square root of 25 over 2. Negative 3 squared is 9. Then the minus 4 times the 1 times the negative 4 is a plus 16. 9 plus 16 is 25. I can clean up that square root of 25. Square root of 25 is just 5. So here I do have to set up 2 so that I can clean this up. I need the 3 plus 5 over 2, and I need the 3 minus 5 over 2, because I can combine the 3 with the 5. 3 plus 5 is 8. 8 over 2 is 4. 3 minus 5 is a negative 2. Negative 2 over 2 is a negative 2. My answers are 4 and negative 2. So just some quick comments. If you have an equation where you have decimals, you're still plugging off your A's, B's, C's the same here. It just makes it a little more difficult to deal with under the square root. So what you would do is there's one number behind the decimal, so you'd move everyone's decimal one place. Even if it doesn't have a decimal, that means that decimal's behind it, and you'll move the decimal one place. And you change this to 3x squared minus 1x plus 20 equals 0. And so now you have something that doesn't have the decimals. So notice on the 2, I moved it 1, so I had to fill that in with a 0. If it was a fraction instead, you would use your least common denominator. Multiply through by your least common denominator so that you can rid your equation of the fraction. If you're comfortable, you don't have to do that. You can just leave the fraction there. Same with the decimal. So when I multiply that one through by the least common denominator, I can cancel the denominators out. So 6 divides by 3, 2. So 2 times 2 is 4. 2 goes into 6, 3. 3 times 1 is 3. I left my signs in place. And then that last piece didn't have a denominator, so just 6 times 1. Signs were left in place and everything because I wasn't multiplying by negatives. So that's what you can do for the decimals and the fractions so that you get something that's easier to work with. From there, you're taking your ABC, plugging it into the equations the same way we just did with those 3 examples before. Another note on number 3, that's one that we could have easily factored. If you get an answer that doesn't have a square root or an I in it, that meant you would have been able to factor it. And factoring is always easier, or I should say quicker, if you know how to factor. If you struggle with your factor, then sometimes the quadratic formula ends up being faster. There we have our quadratic formula.